is not a soundtrack. It's not a film score. It's not a sound effect some editor dropped in for atmosphere. That is a real recording captured in the atmosphere of another planet. That is Venus speaking. And when NASA's engineers first heard it, they didn't celebrate. They went quiet, because what they were hearing shouldn't exist. Here's what we thought we knew about Venus. It's hell, literally. Surface temperatures of 465 degrees Celsius, hot enough to melt lead. Atmospheric pressure 90 times greater than Earth's. Clouds made of sulfuric acid, a sky the color of a bruise. The Soviet Union sent landers there in the 1970s and 80s. The Venera probes, tough machines, built like pressure cookers, and even they only survived on the surface for about 2 hours before Venus crushed and cooked them into silence. 2 hours. That's all Venus gave them. So when scientists talk about Venus, they use words like hostile, like dead, like silent. But here's the thing about silence. Sometimes it's hiding something. In 2020, NASA's Parker Solar Probe, a spacecraft designed primarily to study the Sun, made a close flyby of Venus. It wasn't supposed to make history there. Venus was just a gravitational stepping stone, a pit stop. But as it skimmed through Venus's upper atmosphere, something unexpected happened. One of its instruments lit up. It captured a signal, an electromagnetic signal, a natural radio emission pulsing, shifting, breathing, right inside Venus's ionosphere. And when scientists converted that electromagnetic data into audio, you already heard what happened. Now, let's be precise, because this is where it gets genuinely fascinating, and we owe you the real science. That recording isn't a voice in the way you and I speak. Venus doesn't have a mouth. It doesn't have vocal cords. What it has is something arguably stranger. Venus has a plasma environment. Its ionosphere, its uppermost layer of its atmosphere, is filled with charged particles, electrons and ions, constantly interacting with the solar wind blasting in from the sun. And those interactions, they produce natural radio waves. Think of it like this. You know how when you put a seashell to your ear, you hear a sound? That's not the ocean. That's air pressure swirling inside the shell, the environment itself vibrating against you. What Parker captured is Venus's environment vibrating, the atmosphere of an entire planet resonating. But here's where the story twists. When scientists analyzed the data, they realized the signal confirmed something alarming. Venus's ionosphere had changed. Back in 1992, the Galileo spacecraft also flew past Venus and measured its ionosphere. The density back then was far higher. But in 2020, Parker's readings showed an ionosphere dramatically thinner than expected. Venus had lost atmosphere. The solar wind, that relentless stream of charged particles from the sun, had been steadily stripping Venus's upper atmosphere away, particle by particle, over millions of years. That strange, haunting audio, it's not just eerie, it's a death rattle. It's the sound of a planet slowly being eroded by its own star. And that should terrify you, not because of Venus, but because of what it tells us about us. Here's the part of this story that almost nobody talks about. Venus wasn't hell. Current models suggest that billions of years ago, Venus may have had liquid water oceans, a temperate climate, conditions that, at least on paper, weren't entirely unlike early Earth. Same size, same mass, same distance from the sun, roughly. Twin planets by almost every measure. And then, something went wrong. A runaway greenhouse effect, possibly triggered by increased solar radiation, possibly by volcanic activity, possibly by both, began to cook the planet. The oceans evaporated. Water vapor, a powerful greenhouse gas, trapped more heat. More evaporation, more heat, a vicious, unstoppable loop. Within geological time, which is to say over millions of years, Venus transformed from something potentially habitable into the pressure cooker hellscape the Venera probes died inside. And the ionosphere that Parker detected, that thin, whispering shell of plasma, is what's left. It's the ghost of an atmosphere that was once much more substantial before the solar wind began its slow, patient work of dismantling it. So when you hear that recording again, and you will hear it again before this video ends, understand what you're actually listening to. You're listening to the electromagnetic whisper of a dying ionosphere, a thinning shield, a planet that lost its protection and has been paying for it ever since. This is the part where science stops being history and starts being warning. Earth has a magnetic field, Venus doesn't, or at least it has an extremely weak one, and that difference is everything. Our magnetic field deflects the solar wind. It's a planetary force field essentially, invisible, taken for granted, and absolutely critical to the existence of every living thing on this planet. Venus has no such protection, and so the solar wind does what it likes. The Parker Solar Probe's accidental discovery gave scientists the most detailed measurement yet of just how fast Venus is losing its ionosphere, and the implications reach far beyond Venus. Because here's the question that haunts planetary scientists now. What if Earth's magnetic field weakened? It's not science fiction. Earth's magnetic field has reversed before, dozens of times in geological history. During those reversals, the field weakens significantly. We're currently in a period of gradual weakening. The field has lost roughly 9% of its strength over the last 170 years. 9% in 170 years. Nobody is saying Earth is becoming Venus. That's not what the data suggests. But Parker's Venus flyby gave us a real-time portrait of what happens to an atmosphere without a shield, what the solar wind does, given time and opportunity. It whispers first, then it strips you bare. NASA's Parker Solar Probe wasn't sent to Venus to listen. It was just passing through. But in that brief window, skimming the edge of a planet we thought we understood, it caught something that rewrote our picture of Venus, raised urgent questions about planetary atmospheres, and produced a sound that no human had ever heard before. Not a voice, not a message, not a cry for help. Just a planet doing what dying things do, making noise on the way out. The universe isn't silent. We just haven't always known to listen.